We are now living in the modern electric age, and we are surrounded by gadgets, devices, and cars that rely on batteries to power them. However, with all this great power comes great responsibility, the responsibility of cleaning it all up. If these batteries aren't disposed of properly, they could leach chemicals into the environment and potentially light fires across garbage dumps worldwide. Imagine a Samsung Galaxy Note fire, but 10 times as big for every battery. To prevent this mass-scale dumpster fire situation, batteries can be disposed of properly in two ways. These two ways are reusing the batteries and recycling the batteries. Because this is an unexplored territory, the best way to dispose of batteries hasn't been chosen yet, leaving both of these options as viable avenues. Today, we will explore these two disposal options and the companies pioneering these industries. Many of these companies are small and young companies, but don't let that fool you. They could become massive, and you could be the first to know about them. In this video, I will explain the challenges of reusing batteries or recycling batteries, and the companies that are working on these challenges. Then you can decide for yourself which method you think is going to dominate. Let's dive into reusing, repurposing, and refurbishing batteries for a second life. The ultimate purpose of reusing batteries is to give them a second life because they still have useful and valuable capacity and performance. The most notable case would be reusing an EV battery because of its large size and capacity for storing power on the grid, in a building backup system, or in a home. These applications cycle the battery less, allowing it to live a long, prosperous second life. A battery would be slated for one of these uses after it degrades to about 80% of its original capacity, where the car owner would be frustrated by its decreased range, acceleration, and other characteristics. Plus, the car would probably just feel old. To get a picture of when an EV battery reaches this state, a recent Tesla mileage report showed that about 90% of battery capacity remained after 275,000 kilometers, or 170,000 miles. And assuming a linear degradation to 80% battery capacity, this would occur at about 550,000 kilometers, or 340,000 miles. And how many people really drive their car for that long? When the electric vehicle reaches about 80% battery capacity remaining, the EV owner will get frustrated, want to get rid of their car, and then their battery can be given a second life. What are the challenges to repurposing their old battery for a new use? There are three main challenges that exist. The first challenge is the existence of various types of batteries. These batteries differ in size, chemistry, and geometric shapes, all differing from one manufacturer to the next, causing all the batteries to act a little differently. The second challenge is that used battery standards and classifications haven't been developed yet. These standards would give information on the state of the battery, including its remaining capacity, and could break the batteries into different tiers. Lastly, the third challenge is that the refurbishing or remanufacturing process is still costly. Because this work isn't being done on a very large scale, the process is still expensive. This matters because the falling costs of new batteries could close the gap between new and old batteries, making old batteries less of an attractive storage option. An MIT study said that old batteries would have to be sold for about 60% of their original price in order to make it profitable. However, to bring down the price of refurbishing batteries, the original EV manufacturers like Tesla and Nissan can design their batteries with reuse in mind, making them more accessible in the chassis of a car and standardizing the physical dimensions. For example, all the Teslas have a flat battery pack on the bottom of their car, which you can imagine would make it easier to pack them all together in a second life battery pack. With all these challenges in mind, opportunity exists for enterprising companies. Some of these companies include BTU Storage Solutions, Repurpose Energy, Smartville Energy, Rejoule, 4R Energy, Umicore, CleanSpark, and there's probably some more out there as well. With all these enterprising companies diving into the battery reuse space, let's talk about some of the progress they've made. For example, Repurpose is developing a process to test battery cell degradation in as little as 1 minute, versus the conventional time of 1 whole day. This innovation could drastically increase the throughput of screening batteries. However, before batteries are even screened in a testing center, Rejoule is developing software that can optimize a battery during its use in an EV and measure the real-time state of health of that battery. If they're able to achieve this, then a testing center for second life battery screening may not be even necessary. After the batteries have been screened and sorted, they are ready for use in a battery storage system. BTU has developed battery storage systems for the grid, and they have completed about 11 projects in California since 2008, totaling 100 megawatt hours approximately. Recently, they announced the largest storage deployment in the US using Second Life EV batteries in about mid-May. Once the battery storage system has been built, it's time to make sure it can operate safely. Repurpose is developing a non-destructive fire suppression system. This will put out dangerous fires and minimize the risks to other equipment and people nearby. Lastly, after the battery storage system has been built and the proper safety measures have been taken, CleanSpark has developed an advanced energy software and control technology that allows battery storage operators to optimize both the lifespan of their batteries and the economic profitability. Ultimately, these companies and many others are developing technology to screen batteries, assemble them into storage products, and create control systems for safe and profitable operation of these storage systems. However, sometimes batteries are beyond saving and they can no longer be reused. Once they can no longer be reused, it is time for them to be recycled. However, you still might be asking yourself, why reuse the batteries? Why can't we just throw them away? I like the story by Elon Musk where he told his SpaceX team to imagine that their rocket falling out of the sky was a pallet of cash. Would they try to save this pallet of cash before it crashed and burned? In a similar manner, you can think of EV batteries in the same way. Before you throw out an EV battery with tons of valuable minerals and metals into a landfill, would you try to salvage these parts? Well, if you would like to recycle these batteries, a few different methods exist. One method is a high temperature smelting and extraction process. It is very energy intensive, it creates toxic chemical emissions, and it does not recover all the valuable battery materials. Another method is hydrometallurgical processing, which is basically a big fancy word for using a physical grinding process and then a series of chemical treatments to extract and isolate almost all of the valuable battery materials. Firstly, the batteries are discharged, grounded up, and then the valuable metals are leached away using a series of chemical treatments. This is a newer method which is less energy intensive and recovers nearly 100% of the valuable battery materials, such as nickel, cobalt, lithium, manganese, and a few others. Numerous companies have sprung up into the battery recycling space using this hydrometallurgical processing technology. These include Canadian-based Li-Cycle, Redwood Materials, founded by the former CTO of Tesla, American Manganese, Duesenfeld, a German company with the link in the description to a fully charged video. Check them out, they make great videos on electric cars. Retrieve Technologies, Onto Technologies, and probably a lot more as well. With all these companies jumping into the hydrometallurgical processing space, they have developed some notable progress. For example, Li-Cycle has developed a hydrometallurgical process that recovers about 80 to 100% of the battery materials. To implement this, they are constructing a hub and spoke model. Basically, this means that some of their facilities act as a spoke and are near the largest battery consolidation points, where they then discharge the power from the batteries, allowing them to ship more batteries in one container truck. Then, they ship all these batteries to the hub, where they can be recycled in large volumes. The hubs recover all the valuable battery materials and convert them into battery material precursors, which are basically fresh ingredients for new batteries. In Rochester, New York, they have built a spoke that can process approximately 5,000 tons a year of used batteries. They also have spokes planned for Europe and Asia, and they have a hub planned for North America, Europe, and Asia as well. Besides Li-Cycle, another big player is Redwood Materials, founded by the former CTO of Tesla, J.B. Straubel, in 2017. He gained a lot of experience and knowledge in the battery space while working at Tesla, and he has gone on to form his own company. Not a lot of information is available about what Redwood Materials is doing or the technology that they are developing, but they are expanding in northern Nevada, which is near the Tesla Gigafactory, indicating they will likely have a strong business relationship with Tesla. And even though not much information is known, they will likely become a formidable competitor and a leader in the battery recycling space. Ultimately, these companies are working to develop a fully closed loop system, recycling all the valuable metals from the batteries that have been used for producing new batteries. As companies push forward in both the battery recycling and the battery reuse space, it is likely we will see both of these methods be used. Batteries will be reused if possible, and then once they are no longer useful, they will be recycled, even if it's their first, second, or third life. As the amount of EVs and other battery gadgets grow exponentially, these industries will grow with it and become valuable, prosperous industries in what seems like the blink of an eye. Okay, that's it for this video. If you're still watching, you're awesome. Thank you so much. Please leave a like on the video, subscribe to the channel, and come back for more videos in the future. Also, leave a comment. Which battery disposal method do you think is most promising? Do you think battery storage systems could revolutionize the power grid? Will Tesla and Redwood Materials dominate any space that has electricity and batteries in it? Or if you have any ideas about other battery topics, drop it below and I read all the comments. If you're interested in even learning more about topics like this, check out the Twitter, but more importantly, check out the Discord as well. Join the Discord and hopefully we can build a community that likes to talk about technology topics like batteries, electric cars, space, rockets, all sorts of different things. If you really like this content and you want to support the channel, check out the Patreon in the description as well. Check out all the different tiers I have made, which hopefully make it accessible to anyone to donate to the channel. All of your support is greatly appreciated, and all of the money will be put back into making better videos. So again, thank you for watching and have a great day.